Aloha and welcome. In this video, we're going to be talking about searching in algorithms. So let's go ahead and open up our textbook. So an algorithm is simply a sequence of steps that you're going to need to do in order to get something done. So when you think of your larger project, you may break that up into smaller parts and then execute. And each part will be a logical section, and you'll work through that through a series of steps. Those series of steps, basically, it's an algorithm. So a linear search is going to be an algorithm that starts at the beginning of a list and it goes through element by element until it finds the keyword that you're looking for or until it's not found at all. So if we take a look at our animation here, this is a linear search where we're looking for 14. So we look at 6, it's not in there. Then it compares 24, it's not that. Looks at 16, it's not there. And then it looks at 14. So it finds it on the fourth try here. And you'll notice that when you're doing a linear search, the length of time it takes to find it is going to be related to how far it has to search in order to find this. So you can see that linear search here isn't very efficient. So if we look for something that's not in there at all, like 11, it's going to have to search through all elements. So if we have n number of elements, it's going to have to do n number of searches. If each one of those takes you a certain amount of time, you're going to have n times that amount of time to actually find it. Small numbers, like if you've got 5 nodes or 10 nodes, that's not going to take that long. But let's say you're doing that 10 node search and you're doing it in a loop of 100 times or 1,000 times, or let's say you have a large data structure here. Let's say you have a list of 1 million data points, and let's say each one of those data point comparisons takes you a millisecond or two. That time adds up. You're going to be sitting there for a second or two, and that's a long time in computer time. So you don't want to be using inefficient search methods like linear search here. So getting into here, we're going to look at the code that you would implement a linear search with. So here you can see we have a linear search class. We have our linear search method set up here. And all we're doing is we're taking in an array of numbers. We're finding our search key. Then we're going through there. We're looping through each one saying, hey, is it this one? And if it is, we're going to return the index of it. If not, we're going to return a -1 after we've gone through everything. So over here, we set up an array of integers, integers. Then we go down here, we print them all out for everybody to see. Then we say, hey, give me a number. Then we search for that number. And that's how you would implement it. Getting down here, we're going to learn we're going to go through and just kind of solidify in our mind, how long it takes to find things. So how many list elements will be compared to find 77? So 77 is over here. So you're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. You're looking at 9 searches there. So go through here. It's going to ask you to find 114. That's easier. Then what if you don't find any at all? So you just count up all the ones here. So as you're looking at this, you're getting the idea that maybe this isn't that efficient. Sure, it's efficient if it's one of the first things you find, but if it's like towards the end of your list, it's going to take a lot more time. And this is where we get into talking about runtime. So an algorithm's runtime is the time it takes for it to execute. So if you have a comparison that takes you a millisecond or a microsecond in this case, the linear search algorithm runtime is up to a second to search a list of 1 million elements, 10 seconds for 10 million. So think about, with Amazon's online store, you got 200 million items. That could take a long time to, look through. So obviously a linear search isn't going to be the method that they use for finding things in there. So, so continuing on, ask questions here about linear search time and calculating the amount of time it takes to, actually do it. And it has you think about like what's the fastest time and what's the, it's trying to find the boundaries to show you how inefficient this, algorithm is. So that's all for this lesson. We're going to be moving into other search methods in the next video. So stay tuned and I'll see you there. If you have any questions about this, if you need to reach out, feel free to email me and I'll be happy to talk with you about it. Have a great day. Bye.